Hey everyone, welcome back. I have the opportunity to work on this beautiful old Denside Ford. And originally this truck came with cruise control. Unfortunately, whoever restored it during the restoration, they lost the cruise control components, all of them. So what they did is they just threw in a old horn style button, which we are going to be ditching with a factory horn button that has the cruise control buttons on. Now, the other challenge is the original components for under the dash as well as under the hood, they're all gone. So what I've done is I have an electronic cruise control that I am going to show you the process of how we can actually use the factory buttons. It's going to make this thing modern, but still have that old school feel and look. Okay, this is the actual cruise control unit. It's the modern unit. Now, this control unit is made by many different manufacturers. I have got them from many different manufacturers on different builds, and they all pretty much look the same. The instructions are pretty much the same. This one here has a cable routed over to the engine, and it is going to be the throttle actuator. So that part of it, you can just follow the instructions. What I want to get more into is the electronic control side of this. So I need to figure out how I can get all of these wired in so the cruise can work. All right, what I'm going to try and do is explain to the best of my abilities on how this works. So from what I understand from reading, looking at diagrams and so on, the regular horn did not have a horn relay, which I thought it did because it's in the instructions without cruise control or in the wiring diagram. So anyway, push the buttons, connects these, honks the horn, yippee. Here's what we have here. So with this, you would think that we have all of these buttons here, that we would have a whole bunch of wires sticking out the back side of this. Well, turns out we do not. We only have 3 actual wires. And what we have is a switch that changes the resistance in here, and it is sealed, so you can't even actually really take a good look inside. Everything is sealed in there. So I know that we have 120 ohm resistor, and we have 100 or 680 ohm resistor, as well as we found out with a little bit of help that the off button doesn't work. So if I take and I depress the horn, I end up having power, actually the yellow and the black wire connected. So that's got continuity. And if I hit the set Excel button, my blue to black is 680 ohms. If I depress the coast button, the blue to black is 120 ohms. If I depress the resume button, which we are going to totally ignore, it's 2200 ohms. And when I hit the on button, the yellow and blue are connected. So that's a lot. We will just let you read that if you want. Now the off button isn't working, and the whole problem with this is I can't tell this unit that I have different resistance. So I am way over my head on this. So what I did is I called my buddy Steve. I have had the opportunity to know Steve for a long time, and his brain is really big.
What an intro. Thanks.
Yes. He is one of the guys that I always go to when I have electronics questions. He plays with a lot of cool projects, and he is just a genius. And anyways, so
swollen head.
Yeah. So what I did is I called Steve, and he made me a little circuit board and gave me the schematics, and we're going to share those online so that people want to do this, they can actually get that resource. But what's going on here, I'm going to have Steve kind of dumb this down in his words, because I always assume things that everyone knows stuff. So what did you tell me about this here?
Well, basically with this, those 3 wires, you have a ground, you have the yellow wire is basically just your horn, and you can hear the relay clicking when I press it. And then you have the blue wire here, and it is an analog output. And so that analog output, and as Merle explained, the difficulty is with the speed controller itself, it only takes digital inputs, and it has a separate discrete input for on and coast and resume and all that kind of stuff. And so basically this circuit is an analog to digital converter, but then it does a little bit more than that. It has 4 discrete outputs. And so it's simulating the fact that when you push one of these buttons and it's converting from the analog signal into the circuit and then like a relay output on each of the outputs. And so we can put a multi-tester on the outputs here. We can test they are all at 0 volts normally. If we push the on button, for example, then one of the outputs will go high. And in it being high, I mean 12 volts. And so then we can go through and each of those 4 buttons will activate each of the 4 outputs. And then we can take those outputs and feed them directly into the cruise control module. And if it's all hooked up, then it should work perfectly first time.
There is one more complex thing, is what I had said before is without cruise control, there's no horn relay. So the horn relay is like an insulator. So it supplies power to this.
Yep.
As well as insulates it from a short circuit.
Yeah, I wasn't prepared for that question. Yeah, when we're activating the switch, you don't want, in this case, all of the current for the horn is going through that switch, which isn't ideal. In this particular case, the switch itself here is activating the relay, but it's using the current through the relay as a buffer, basically. And then as we press this, like I said, we can hear the relay clicking without it actually shorting out to anything.
Mm-hmm. And so the reason that the off switch didn't work in here is like that I couldn't test it and get it to actually work in on my paperwork is because we figured out that the off switch actually doesn't work. When we hit the on switch, we end up getting a voltage output that pulls high to 12 volts. And when we hit the off switch, the same should happen. And so if he replaces the switch, Steve has actually tested it. If we ground the blue wire
to ground, then it will output the off.
Outputs the off. So what we're going to do is we will focus in on Steve's diagram here, and I'll let him maybe go over and explain it a little bit. So if someone's needing to build this, they actually have the resource with an explanation. All right, Steve is going to take you through his drawing a little bit, but the real deal is, if you know an electronics guy, this should be a full enough schematic that they could be able to build this circuit for you. And I'm going to let Steve take over on this.
Okay, so if we look at this section here, this is kind of just showing what the input from the steering wheel is looking like. And so we have 4 switches here. Switch 1 is pulling our sense wire to ground. This switch is pulling it to 12 volts. And again, for right now, we're ignoring the horn circuit because it's separate. This switch is connecting a 680 ohm resistor to ground, and this switch is a 120 ohm resistor to ground. So this is our steering wheel side of it. This sense wire ends up right here. And so this is the input to this particular module. And so what happens is this ends up being an analog signal. We have a voltage divider here, and you can see in my notes, it says that it's normally floating at 9.2 volts. And when we depress the 120 ohm switch, then we end up with 1.25 volts on that line, and the 680 ohm results in 4.33 volts. So the whole part of this circuit here is we end up with a voltage divider and comparator circuit. And so we use a bunch of resistors here to create a bunch of different voltages, and then we're comparing that input to those different voltages through all of these comparators. And so if you look closely here, This particular voltage, 0.6 volts, is feeding 2 comparators. Actually, let me correct that. It's feeding these 2 comparators. This one here is looking for anything under 0.6 volts. And if it's under 6 volts, then this output is on. Because remember, the input is floating, and so that would be the off switch would pull the circuit to the input circuit to ground, and then this would become active. This one here, you can see these 2 comparators are connected together, and so it's actually looking for a voltage greater than 0.6 volts and less than 2.5 volts. This one is looking for, it's also connected, the 2 comparators are connected, so it's looking for a window voltage here, and this last one here is looking for any voltage that's higher than its input, which is 10.6 volts. All right, so if you understand electronics, then this kind of makes sense. If this is all new to you, then kind of just think about it as a circuit that is comparing the 4 different voltages and giving us output based on what those 4 voltages. Now, if you're wondering about the fact that everything is marked with 12 volts, and if you know anything about automotive, you know that it's rarely exactly 12 volts. But everything here is based on a voltage divider or a ratio. And so whether your engine or your vehicle voltage is 12, 13, 14 volts, whatever it is, because it's a ratio, everything will scale properly, and the whole circuit will continue to work whether it's 12 or 13 volts. All of those actual measurements will change slightly, but because it's a ratio, they will continue to work.
Okay, so this magic, Steve, what's your comment on this?
Well, you can see that I hand prototyped this board, and in the end, it ended up being a fair bit of work just to hand wire it all. I probably should have just skipped right to a circuit board design. I've done that for many years, and it would have been quicker and easier to design a circuit board. So this does tend to be kind of a one-off circuit. If somebody out there wants to design a circuit board, there's the schematic for it, and you can easily input that and create a little circuit board for yourself.
Okay, we have a little bit of a problem, well, two in this one. First of all of these aftermarket cruise controls are pretty much carbon copy the same, different brands, different names on them, whatever. Anyways, I'm pretty sure one company makes these for everyone. That's one problem that we run into, because this says set Excel and coast, and these are the buttons that we're going to be using. But if we look on here, we have resume Excel and set coast is the other ones that we have on here. So set coast, resume Excel. So I'm going to be using coast and set on here, and Excel, which will also be resume there. And he's going to have to realize that as well. I believe this is out of a newer unit. I haven't looked it up at all, but it has a resume button, and nowhere in any of the older stuff can I find anywhere where we have 2200 ohms coming out of this. So this is going to get ignored. This is going to be resume Excel. This is going to be set coast. And if he finds another button assembly, this can be changed at a later date, but I'm having a hard time where we live finding components for this. So this is what we're going with. Okay, this is the harness coming out of the steering column. And on different years, there was different colors, as well as some aftermarket signal light switch, which I had actually used parts out of to get this one because I couldn't actually get a proper switch for this, which is kind of beyond me. But anyway, what I want to do is I'm going to go over to the bench, and I will show you on the bench what we're dealing with here. Okay, so this is the layout, vehicle harness side and the steering harness side. And we have all these generic that you can read. This is for other things. Now, the two that we're worried about is the yellow wire and the blue yellow wire, which is blue on the back of the switch. So the yellow is the horn relay ground, but it is also powered for the on circuit. And then the blue wire itself is the analog cruise output. If we look at this in a schematic, forgive this, this was a, okay, we got to figure it out, let's throw this away deal. So we have the horn relay coil, and when the horn is depressed, it is actually grounded. When it is not depressed, and we hit the on button, it actually is pulled up, or it pulls the blue wire up to 12 volts. So that's our on signal. So yellow, blue, and then the black is just grounded in the steering column. When we put it together, I'll show you that. Steve is actually helping me, helped me on many problems that I've had, and I really appreciate that he's helping me on this one. So
Yeah, no problem.
thanks a whole bunch.
Yeah, these are fun little puzzles to solve, and yeah, it's going to be fun to see it all come together too.
We'll have to take you for a rip in the truck.
There we go.
All right.
It's a deal.
Thanks.
Okay, thank you, Mark.
I'm super fortunate to have a good friend like Steve. He is always reliable, always helps me out. Carrying on with this, I'm going to get it together. So in the automotive world, this is called resistive multiplexing. And those kind of circuits are used in a lot of different things. So I'm sure that we'll have Steve help us with more projects like that in the future. But for now, I'm going to get this together. And once it's together and we're testing it, we'll bring you back. I thought I'd just show really quick. These two wires get plugged onto these plugs. This is the ground, and it gets just shoved into one of the puller holes. And the steering wheel, we tried to replace it, but the splines weren't the same in here. So we're still got to look for steering wheel for this truck, but it's coming together. Okay, talking about discrepancies in wiring diagrams that are available for 78 and 79. Well, here is some of them. So this wiring diagram in here, where this big yellow wire coming out here that someone's already tapped into for power, well, that yellow wire is actually the yellow wire coming out of the steering column here. And it originally, I believe, with the non-relay fed power in, and then the black wire, which was on the blue, honked the horn because this is power here. And when I put power to the blue yellow wire, well, it honks the horn. So not sure if wiring harnesses got changed or what, but that ain't gonna work, because now if I do that, this horn button that we have, if I depress the horn, the yellow wire is common to the black wire, which is a ground. So me thinking, oh, this is gonna be easy, I'm gonna plug it together, hopefully the relay's in there, works, blah, blah, blah. I hit the horn button and the lights go dim. The horn doesn't honk. So what I need to do now is I actually need to take and use that horn relay that I got. And we're gonna clip into this wire, and I'm gonna do it on the side of the signal switch, because this all can be replaced, and I'll put a nice plug on it and everything. But what we have here is, if you look on this diagram, that yellow wire goes exactly to the, sorry, that isn't what I was looking at. The yellow wire. Oh, yes. The yellow wire goes to the headlight switch and powers the horn relay, which I am going to do. I will clip into the signal switch side, and then I'm going to have to figure out the rest here so we can still feed the horn circuit. So I'm going to have to clip that wire too. I wonder if I reverse it. You know what? I'm going to do a tiny bit more figuring out and get it wired up and show you what I come up with. Okay, here's the solution. So I ended up cutting the yellow blue wire here and the dark blue wire, and I have spliced in the horn relay, and now I have my module wire, but easier than this. There's the drawing. So this is exactly what I did. So we have the headlight switch powering the relay. We have the dark blue wire that goes to blue yellow powering the horn. Then this yellow blue wire was cut there, and this goes from the horn cruise switch, and the blue wire, the dark blue wire coming out, now goes to Steve's new Wonder Magic module, and that will work. Of course, run into another snag. Now, this could be because I misinterpreted the wiring diagram from the cruise control unit. So what I need to say is it is a Rostra unit, and I called their tech department. Great to deal with. What we had thought was the input to turn this on, that was a quick momentary input, is actually needs to be a latching input. So we have the options of on and off on this, and we were going to get a latching relay. That's a high side trigger latching relay, which is a little bit difficult to get right now, at least in time to have this truck done, as well as the off switch doesn't work properly. You can get latching relays that is a push on, push off. But because the switch is a little bit sketchy, safety reasons and so on, I talked to the owner of the truck, and we ended up doing a just little latching switch to turn it on and off. So that switch, we just hit on and off, and it is on to the cruise wire. If you were going to use a latching relay, we would use the on to latch it, and then we would have the wire going out to the cruise unit, and we would have the on or the off used to turn that relay off. So a little bit more of a hiccup, not a huge deal. If he does decide to try and find another button for the horn cruise control, this can easily be changed over to this latching relay. So in other words, our little computer that we have right now, we have our blue sense wire coming in, we have our ground, we have the 12 volt power, and then on here we have our yellow wire, which is the Excel and the cruise unit, and the dark green, which is the coast and set. So I just have to get this mounted up underneath the dash, and then we will be going out to test drive it. And I just put in that little tiny button right there, just mounted it under the dash. So they said it would be easy. Now, I ran into one more thing that I have to share with you. I took it out and the cruise didn't work. I went through the diagnostic procedure and we had a switch that was not working properly. It turned out to be the brake lights, and what it is there isn't enough resistance in the, or there isn't enough of a ground signal through the taillight bulbs in this. Now, normally that's a thing with LED lights, but in this truck, just the bulbs in this truck are not giving a ground brake signal through the bulbs. So we need that, and I had to hook up a relay. So I will show you that diagram for that. Okay, this wiring in here, not my deal. It was in there. I guess it's working. I'm not going to worry about it right now. So that right there is the little relay. I'm not sure if you can hear it clicking. When I hit the brake pedal, it clicks. Okay, so the wiring diagram for it is, first of all, I'll explain the relay. This is the normally closed output or input, and the normally open output or input, depending on how you're using the relay. So when the coil between 85 and 86 is energized, what happens is it puts power from, or it makes 30 and 87 common. When it's not energized, 30 and 87A are common. So at rest, the brake signal is connected between the ground and 87A. So the module, when it's at rest, is grounded through the brake pedal, which it needs. When you hit the brakes, you energize the coil and you break the connection between 87A and you put it onto 87. So with the brake pedal hooked up, 87 and 30 are connected, and we just do not have a wire to 87 because we don't need it. All right, so now it is time to go out and test. It's going to work perfectly, right? I guess we'll keep our fingers crossed. Okay, I am going to test the cruise out. And too bad it's ugly outside, but is what it is. So cruise is on, and I'll get up to a higher speed here, and we will set it. And look at that, we have cruise control. Now, if I hit the brake, yeah, it cancels it. So we'll set it again. And if I hit the accel, yeah, it accelerates. If I hit the coast, coasts. And the on-off switch works. So, success. No more issues. We got it sorted out. I really have to say a special thank you to Steve, as well as Thomas from Rostra. He was a big help, especially in figuring out the latching part of the setup that we need, as well as the brake pedal. So this is a wrap on this video. Thanks for watching. Hope you liked it. Please like, share, and subscribe, and don't be scared. Get your old stuff working again.